Magma beneath the surface of the Yellowstone supervolcano's caldera drives a wealth of hydrothermal activity. How does this process work? Rainwater seeps into the ground and collects in underground reservoirs. Rock heated by magma domes pushing up through the earth in turn heats the water to temperatures as hot as 350 degrees Celsius. This heat causes the water to expand and push back upwards towards the surface, where it manifests itself as hot springs, geysers, fumaroles, and mudpots. Hot springs occur when the superheated water slowly emerges at the surface, spreads out, cools, and re-enters the ground. One of the most notable of these at Yellowstone is the Grand Prismatic Springs, which gets its name from its rainbow-like coloration. How does this happen?
Water at the center of the hot spring comes straight from the depths of the earth and is so hot at 189 degrees that organisms cannot survive. So the center of the spring appears blue simply due to the scattering of blue wavelengths of light, the same reason that the sky appears blue. As the water spreads out across the 370-foot diameter of the pool, it begins to cool. Changes in temperature are marked by concentric color changes. Why? Different microorganisms thrive in each unique temperature zone. Because of the harsh conditions, carotenoids, a yellow to orange pigment, becomes more dominant in the microorganisms. Carotenoids protect bacteria from harsh sunlight and conditions, which there is plenty of in the spring. In the first ring going out from the center, only Cyanococcus can survive, and their carotenoids are a pure yellow. Even further outwards, a larger variety of bacteria can flourish as the water cools further, resulting in increasingly darker shades of orange. The flow of water to the surface is not always this peaceful. When water is repeatedly reheated, it rushes quickly to the surface through fissures in the ground. As the water encounters natural narrow spots or throttles in the rock, it shoots upwards even faster, spewing from the earth in a superheated water eruption. Water rockets through the narrowest part of the fissure of Old Faithful, Yellowstone's iconic geyser, at the speed of sound. Minerals deposited onto the rock threaten to completely obstruct the geyser, making it inactive. Sometimes the natural obstructions in such fissures give way, resulting in an explosion. Alternatively, when water levels are low, it boils away before it can emerge at the surface, resulting in a fumarole or steam vent. Yet again, sometimes water collects in an impermeable area on the surface and creates a small pool. Steam rises through the ground and heats the water at the surface. Hydrogen sulfide in the water feeds microorganisms that in turn give off sulfuric acid. This acid eats away at the surrounding rock, turning it into a clay-mud mixture. The result? Boiling mud. Minerals in the rock sometimes tint the mud with a variety of colors, which is why they are sometimes referred to as paint pots. And if the boiling mud gets out of hand, it's called a mud volcano.
All of these features are profoundly interconnected. Changes in the water table, in the pressure of one geyser, or in the discharge rate of a hot spring will affect other hydrothermal features around them.